Okay, remainder and factor theorems. So I've got some summaries of the remainder theorem and factor theorem. So just read them. Okay, if a polynomial p of x is divided by x minus k, then the remainder is p of k. Okay, and that's a remainder theorem. And the factor theorem is for a polynomial p of x, if p of k is 0, then x minus k is a factor of the polynomials. Okay, and converse of the factor theorem, for a polynomial p of x, if x minus k is a factor of the polynomial, then p of k is 0. So these are like opposite. Okay, so converse means just it works for both ways, opposite. Okay, and then if we have to factorize polynomials, if x minus k is a factor of polynomial p of x, then k is a factor of the constant term of the polynomial. Okay, so we'll do some examples and you'll understand what it really means. So first question, let's have a look. Find the remainder when f of x equals x cubed minus 4x squared plus x plus 6 is divided by x minus 2. Alright, so what does that really mean? I'm just going to have a look. Now, part A, we're looking for, I'm going to write A here, looking for R, the remainder, we don't know. Okay, and it says here divided by x minus 2. So that x minus 2 up here is a factor. So I'm just going to put that in there as my factor. So if I get the 0, that'll sort of answer my question, wouldn't it? If when I put the x equals 2 there, and if I get 0, it's a factor. Alright, so let's have a look. 2 cubed minus 4, 2 squared plus 2 plus 6. You put that in your calculator, you will get 0. So therefore, the remainder is 0. Okay? B. Is x minus 2 a factor of f of x? Of course it is. From A, we proved it. It is. Okay. C. Now it's a divided. All right, then we just divide it. We're just doing what the question tells us to do. X minus 2. Okay, so I'll go x squared, x cubed minus 2x squared. Now, I'm just going to do minus here. So minus and then making the plus. Okay, now cancel it. I'll get minus 2x squared down x minus 2x. You times it, minus 2x squared plus 4x. But if I take away, I'll get that. I'll get minus 3x and bring it down 6. It'll be minus 3. Okay, so since they're the same, if I take it away, it will get 0. Okay, so that's what we did, division there, right there. And the last question says, factorize it f of x fully and write it f of x as a product of its factors. Okay, so I'm going to do that. So f of x, which is same as p of x, equals, what is it? My divisor and a quotient, and I don't have to do plus 0 because it doesn't really matter, but it says here fully factorize it. So these can be factorized. I'm just going to put it in. And what's a factor? 1 and 3 because it's a prime. And it's going to be negative, so I'm going to have it, the bigger number has to be negative, and this is when you times it's negatives and one of them has to be positive. So the fully factorized one will be this. Excellent. Okay, next one. Question 2. So part A, show that, okay, so it's sort of like a proving stuff, show that x minus 3 is not a factor of the p of x. So if I put 3 as my factor, and if this one gets it, gets the 0, then it's a factor. And if it doesn't get 0, it's not a factor. So if you put that in your calculator, you will get 140. Okay, so it's not a 0, so it's not a factor. Okay, therefore, x minus 3 is not a factor of p of x. Okay. B. Find the value of k such that x minus 3 is a factor. We're not talking about this question. It's completely different. So this time x minus 3 is a factor of p of x, but we don't have p of x, so we only have q of x, which is q minus 5x plus k. And if, well, x minus 3 is the factor, if I put that in, I should get 0 as well. So x minus 3 is factor, so I'm just going to put that in, which is 2, 3, q minus 5, 3 plus k equals 0. So if I do that, what do I get? 54 minus 15 plus k equals 0. 39 plus k equals 0. Therefore, k equals minus, 39. Okay, done. Okay, next question. Here we go. Evaluate. So it means I need to find the value. Okay, it's not a proving or expression or anything. It just find the value of it. So let's have a look. X cubed plus 3x squared minus 2x plus 1. It's similar to this. I'm just going to expand all the stuff I've got here. So what's this one, guys? It's a x squared, it's a perfect square, minus 2x plus 1. So I'm just going to expand this one. 2bx plus b plus cx plus d. Okay, so I expanded. And I'm going to put that into the order of the power. This one, I'll go c minus 2bx plus b plus d. Okay, now I need to equate this, all right? So I'm going to use different color. So can you see this equating with this? So therefore, I can say a equals 1. Okay, so because they're the same in a way. And that is equating with that. So my b equals 3. All right, so I've got these two ready. Now I'm going to equate these other ones. So c minus 2b need to be equals minus 2. So what I'm just doing now is equating. Okay. And we know b is 3. So I'm going to go with c minus 2, 3 equals minus 2, c equals 4. Okay, and then b plus d equals 1. And we know that b is 3. So what I've got here is a equals 1, b equals 3, c equals 4, d equals minus 2. All right, that's not too bad. The next question. Okay. All right, so next question, it says a polynomial with the leading terms 2x to the power 4 has zeros. They're the factors, guys. So in this case, I will go, this will be x plus 2. That's just x. And that's x minus 1. That's x minus 3. So they are the factors. Okay? So I'm going to write p of x equals, I'm going to write everything here. Now, one thing we have to be careful is leading term is 2x cubed. So if I just times all these, that will be my leading term. Just I'm going to get x power 4. I don't get 2. So I'm just going to times 2 here. That way I can guarantee my leading term is 2x to the power of 4. Okay, so I'm going to expand this because it's a polynomial. So I need to write it with the powers with it. So I'm going to go one at a time. So I'm going to do this first. X squared minus 4x plus 3. Because the middle one is the plus and then last one is a times. So I can do that really fast. And I'm going to do this. 4x squared plus 3x plus 2x squared plus 6. And then I'm going to tidy it up a little before I expand it again. It's just easier that way. 6. Okay. And then I expand the whole thing again to, there you go. I've got that leading term there. 3 10 to the power 2. Okay, so my polynomial is that. Well, that's excellent. Now, the last question, 5. Factorize p of x. Now, it hasn't been giving us the divisor here, just giving us the dividend. So how do we do that? We need to look at the constant term here. So try factors of the constant. Now here constant is really minus 12 is really minus 12x to the power of 0, guys. Okay, the x to the power of 0 is what, 1. So that's why it doesn't show it. It should have like a power of 3, 2, 1, 0. Okay, when you say constant term, it's always a x to the power of 0. That's what it's referred to. Constant term, which is minus 12. Factors of minus 12 will be what? Plus minus 1 and plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. So, you know, factors, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So in here, so I'm going to go with the little ones first. So I'm going to put 1 in there. That'll be minus 4. Oh, that's not going to be 0. So the x minus 1 is not a factor. Okay? And then I'm going to do 2. I mean, you can do minus 1, but it doesn't look like it's going to be 0. So I'm just going to go straight into 2. So 2 cubed plus 3, 2 squared minus 4, 2 minus 12. If you put that in a calculator, times it. Yes, it looks like it's 0. So we got a factor here. So therefore, x minus 2 is a factor of px. Now we can do the division since we got the factor. So I'll go x cubed plus 3x squared minus 4x minus 12 and x minus 2. All right, so x squared will give me x cubed minus 2x squared minus plus, let's cancel 5x squared, the next one coming down, plus 5x squared minus 10x minus plus, cancel 6x down minus 12 plus 6. Excellent. So that's 0. So that is my factor here. So let's have a look. P of x equals my divisor, quotient, and I don't have to worry about the remainder because it's 0. And I can factorize fully here. X, what's a factor of 6? That gives us a sum of 5, 3 and 2, then both plus. There you go. That will be my final answer. Well done, people.